Okay, so our second form of phospholipids are sphingomyelins. So this has a new kind of backbone feature. So instead of having glycerol, we are going to have the sphingosine. So I drew the sphingosine here in orange. So it's kind of shown as a little L shape, I guess, in the cartoon form of what these look like. But what the actual structure is here. So there's a couple key features with this molecule. So first off, you'll notice that you don't have an ester linkage to a fatty acid on the very top. So now we're going to have a carbon linkage. So you see here, we have a carbon bond. So the alcohol actually is just kind of poking out the other side and doesn't have anything bonded to it. So we'll have our double bond and then a long chain, saturated chain after that, of 12 carbons, CH2s, and then our CH3 at the end. And then as you go down the second row, you're going to have an amine here. This amine is going to have an amide bond to a fatty acid. And then lastly, we have our alcohol. So this bottom part is similar to what we've seen before. And that's where we have our phosphodiester. Phosphodiester. Bond to an amino alcohol. So this overall is kind of the same, kind of different. It's pretty unique. These are abundant in something called myelin sheaths. So these are important to the structure of our nerve cells and how our nerve cells work. And so, for example, if these sphingomyelins are lost from the myelin sheath, that is what is the cause of multiple sclerosis. So when you lose these sphingomyelins in that myelin sheath, it impairs your nerve cells from working correctly, causes muscle weakness and loss of coordination, and etc. The pretty typical and telltale signs of multiple sclerosis. Okay, so that's where sphingomyelins are different, and make sure you understand the differences between those and the other kinds of phospholipids.